Hey, what's up guys, my name is Jono, welcome back to my Game Engine series. So, last time we basically more or less completed our bash renderer. Check out that video if you haven't already. We implemented the rotating of quads. We basically moved everything to just being a 1x1 quad inside a vertex buffer, which we then controlled via like some matrix transformations every time we submit something new into that vertex buffer. So, now that we've done all of that, I mentioned at the end of last episode that we would now need to move on to something of a stress test for our batch renderer. And this doesn't just literally mean a stress test for the purpose of performance, because we can more or less, like, we don't specifically need to be like concerned about, oh, we better like stress test everything that we ever make to make sure it's fast enough. I don't like falling into the trap of just optimizing without creating anything. Because if you think about it, the purpose of this engine is to create something. We want to create some content. We want to create either a game or maybe like a graphics application or a scene or something like that. And if we're constantly concerned with optimization, we're never going to actually have a final product that we can show to people. Because it's interesting, and this might be a topic for another video, to be honest. Starting this video is strong, right? But anyway, this might be like something a little bit different, but ultimately, like, as a programmer, as someone who's working on this technology, it's really easy to fall into the trap of, check this out, like, this runs really fast. It's taking me a millisecond to render all of this. And then you show it to someone who's like not a programmer, someone who you probably want to share your creation with, and they're like, 1 millisecond, like, yeah, I mean, I guess that's fast. Like, all I can see is what the person's showing in front of me, right? There's no like, oh man, I optimized that. Now it's like, so many less CPU cycles. Oh, have you seen the CPU cache on this? It's so good. No one cares. No one cares, right? We're creating this because we want to show something that someone can enjoy, hopefully, and that is not going to matter. Obviously, if the performance is so bad that we're dropping frames and it's lagging and they can't interact with it, or it's glitching or something, that's terrible. That ruins the experience. But anyway, rant over. I didn't mean to start off the video like that, to be honest, and I might even end up re-recording this. Probably not, though. Let's just roll with it, But I guess the point is, I don't want to stress test this necessarily for like being able to be like, hey guys, check out my engine. It can render 100,000 quads in 3 milliseconds. We're not about that, and I don't really want this engine to be about that. The reason I'm doing this is because, first of all, I need to have a good test set up so that we can see and make sure at all times that we haven't broken anything and that everything is working as expected. As expected meaning that if I leave it running for 5 minutes, it's not going to use increasingly more memory until it crashes or something like that. Meaning that rotated quads and textures and like Z flickering, for example, does not exist. Everything like gets rendered correctly. Are my quads rotating around their actual origin point and not around the origin point of the world, which is something we tested last time. It's important to kind of get all of that stuff down. And again, if you don't have a good solid test case set up, like for example, what happens if we use more than 32 textures? Does it just flush that drawer and then continue on again? Or do we not see our 33rd texture or whatever? So anyway, that is the point of today's episode. I haven't done any work on it at all, so this is all going to be live as if it was a live stream. So we're just going to jump in and we're going to see how we can construct a good test for our batch renderer. Okay, so this is basically what we have so far, right? We have this is what Hazel Engine looks like. We have this full kind of scene here. We can move around using the WASD keys and then the scroll wheel, and I think that is about it. So that's great, and we're demonstrating a number of things here, which is really kind of useful, I guess. First of all, we're demonstrating a texture that is tiled. If you were to look at the actual base of, and I hate that it moves this over here, but if we take a look at this, inside assets, textures, we have this checkerboard texture. You can see that 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 cells across, but obviously inside Hazel, we're rendering a lot more than 8 of these checkerboard kind of cells across, right? Because we're tiling it. Same with this. This is actually being tiled pretty heavily as well, probably the same tiling factor as this. So that's, first of all, demonstrating that it's not just rendering the entire texture, it's actually like we support tiling, which is good. This texture here, it's textured, but it's also rotating. So this is us demonstrating that we can draw a rotated textured quad. This is just a colored quad. This is, I guess, a non-uniform colored quad, meaning we haven't scaled it uniformly. It's, you know, it's the width is different than the height. And then we have a rotated color quad because they flow through different code paths. A rotated texture quad and a rotated colored quad are completely different functions, and we need to test that out. Now, the next biggest thing I would say that we need, first of all, is, yeah, I am interested in the performance. I do want to make sure that we can do that. But more importantly, I want to see how many quads we can actually render and whether or not we can control this kind of limit that we have here. If we scroll up here, we have a max quad limit of 10,000. I want to be able to play around with that max limit and see if I can raise it to 100,000 or lower it to 1,000 and see kind of both the performance implications of that, but also whether or not our renderer will successfully flush everything and start a new batch and start a new draw call if that were to occur. So let's go ahead and make that happen. So one of the things that I like to do is inside our kind of renderer 2D data, I'm going to make another struct called stats, and these are going to be our statistics. And to be honest, I'm kind of trying to avoid having like, you know, I guess shortened variable names and stuff like that, like text. I'd rather write texture in this series, it seems, and just, I guess, for the design of the engine. So that's why I'm writing out statistics and not stats. But I want a few things. So first of all, I want the number of draw calls. So this is interesting because, like, ultimately these statistics, the way that statistics should work for a renderer, because a lot of people get bogged down in, okay, but how do I know when to measure and when to complete measuring? Because draw calls, right? Well, obviously if I measure draw calls every time someone begins and ends a batch, it's always going to be 1. And the answer is yes, it is always going to be 1 because one batch is one draw call. So usually the way that I like to write statistics is they are resettable by the client whenever the client decides to reset those stats, which makes sense. So in other words, what I'm saying is that it's up to Sandbox, it's up to the client to be like, okay, I've completed my like rendering commands or whatever, and now I want to reset my statistics because I want to start again. So that's kind of the idea. So in other words, inside Sandbox 2D, where we actually do all of this rendering stuff, once we finish everything, we're going to reset the stats. Or I guess more realistically, we're going to reset the stats here, right? Because that's kind of like the beginning of our new frame. Okay, so that being said, we'll initialize everything to 0 as well. We don't really need to because we'll call reset, but I still will do this just to make it look a little bit neater. I want to know the draw calls. I want to know the quads, so quad count, we'll say. And then like everything else, I guess we can calculate from quad count. So in other words, if I want to know get total vertex count, then that's obviously going to be quad count times 4, right? And then something like get total, I don't know, do we want a triangle count? I guess not. Index count is going to be quad count times 6. So all of that stuff is like, we don't really need to create actual like points of data for it. And in fact, you know, draw calls and quad count is probably all that we need. I mean, again, memory usage and stuff like that, we can definitely figure out from all of this other data. And if we want that kind of finer grained statistics, then maybe we will do something like that later. Okay, now that we have the statistics thing, I like to make them, I don't like to necessarily add names here. So I'm just going to make it down here and I'll call this stats. This we will call stats because this is called statistics. Okay, so now that we have stats, I really want a function called reset stats. And I'm going to put this at the bottom just because this isn't something that we necessarily need for like distribution versions of Hazel. For Elise, we definitely want it, but we'll have a reset stats function. And I guess we'll also need something that retrieves the statistics, which is where this becomes a little bit I'll say annoying because it's inside renderer 2D data and we may have to move it. So I'm actually going to move this out. I'll have this inside renderer 2D though, because it should be, I guess. We'll have our stats down here and I'll put statistics over here. Okay, so reset stats will return statistics. Oh, sorry, will not return statistics. We need to write a statistics. I guess we'll just have a, we'll just copy it. This shouldn't be very big anyway. So we'll have a get stats function, which will just return this. And then we'll have a reset stats as well. So with these two in mind, let's go ahead and create these functions. Okay, let's just create them manually. I'm gonna go ahead and create them at the very bottom here because they're not really that useful. And in fact, get stats, yeah, okay. So this will return sdata.stats. This will, and let's put these inside the renderer2d namespace. And we're going to have stats here, statistics, and then this will basically just, well, we can just make this really simple and just say that sdata.stats, we're going to memset all of that to just 0. So mem 0 and then size of statistics. All right, and that's pretty much it. Okay, so what is the issue here? We need to make sure that we're in a namespace. Okay, that's good. So back up here then, this becomes renderer2d statistics. And is that it? I think that's it. Yeah, because we already removed it from here. Okay, great. So we have stats now. Now we need to actually count the stats. So let's first of all take the memory address of stats so that we can reset it all to 0. And then let's start our statistic counting. So this is just like a little bit of a helper method. So that doesn't really exist. Neither does this one, right? So or this one, I guess. So we have, or this one. So we have 4 of these functions. So when we do this kind of index count, we're also going to, at the bottom here, do sdata.stats drawCalls plus, okay? Because, oh, sorry, what am I doing? Not drawCalls, quad count plus, because we're drawing a quad. And we'll do that everywhere. So over here as well. And what we'll do is we're going to always leave this at the very bottom, because if anything happens, we can say, you know, if statistics or something like that. And I know I spelled that wrong. Statistics. Sorry, I just had to do that right. If we have, you know, we can do stuff like this basically to compile out stuff if we don't want to collect statistics, so that technically everything will be faster, which is why I'm putting it, you know, I'm just kind of putting it at the bottom. We're going to group them all at the bottom. And if we want to add a macro like that, we can do that. Well, not really a macro, more of like an if, like a preprocessor directive to not compile the code. Okay, that's it, I think, for like the quad counting. So let me just double check that, because I've been talking a lot. Quad count, quad count, quad count, and quad count. Okay, cool. So what we'll do is we'll add in the stuff required for our draw calls. So every time we do a draw command, which is render command draw indexed for us, what we want to do is basically say sdata.stats.drawCalls++. Okay, so clearly, if we reset it every frame like we want to, so over here when we reset it, when we do Hazel renderer2d reset stats, it's going to set them all to 0, and then over here, if we like begin multiple scenes or do whatever, clearly it's going to gather all of them up until the next time we reset it. Also, if we try and draw more quads than we're able to here, then it will also reset it, because it's going to have to flush and redo the thing again, which is actually a good point of us probably wanting to check that, because it doesn't actually do that right now. So we do need to handle that edge case, because you can see that if we try and draw a quad, it just does it, you know, like it just goes in here and it actually tries to add to the vertex buffer. But if the vertex buffer is full, that's going to be a huge issue. So what we actually need to do, because we'll overflow the buffer, like this kind of quad vertex buffer pointer is obviously pointing to somewhere that should be inside quad vertex buffer base, which has obviously a finite size of max vertices times size of quad vertex. So if we overflow that, we overflow the memory there, and we're going to either corrupt our program or crash our program, depending on, you know, if we're in debug mode or release mode. So it's going to be bad. So we definitely need to handle that. So let's just handle that now, I think. It's not particularly difficult. So every time we draw something, which is like over here, the first thing we really need to do is basically, and we can do that, like, I guess I'll do that. We'll have the constants, maybe, I'll do that as the first thing. So basically the idea is that if we have drawn, right, we can go by this index count if we really want to. If we have drawn, if sdata quad index count is greater than our max index count, so max indices, right? Well, we can probably do greater than or equal to, but if we think about it, since this is times 6 and we increase it at the bottom, we should be over it. So if this is greater than max indices, and max indices lives inside renderer 2D data, and this should probably all be static, to be honest. So let's just make that all static. Since it lives inside here, and is that actually going to work? Texture index, yeah, that should be fine. Renderer 2D data max indices. So if this is above our max indices, then we need to basically end first. So we'll do end scene. We'll have to, and this might be slightly problematic because we don't copy the camera, but anyway, we'll see. So end scene, we need to do a flush. I think the flush happens by end scene. So we just basically do end scene and then begin scene. Except the only problem is we need the camera to begin the scene. So let's see what actually happens here. So we bind the textures and we do texture flush. I mean, I guess technically speaking, we don't really need to do all of this because, yeah, I think what we'll do is we'll actually come down here. We'll write a little private function here. And again, this, technically speaking, this doesn't have to be in here. I guess I'll leave it out because since we're not dealing with class members ever, it can be completely private here. So what I'll do is I'll actually, under flush, I'll make a static void. This does feel a little bit dirty though, but we'll say basically start new batch. And start new batch is going to leave a lot of the state already intact. For example, we don't need to reset the camera. We don't need to bind our texture shader because it's already going to be bound. We're just starting a new batch. What we really have to do is just reset all of this stuff and and make sure that we obviously flush and do all of that stuff beforehand. So start new batch will end the batch. So renderer. Yeah, okay. I'm actually not going to do that because, I don't know, we could keep it completely private and enclosed, but it's going to be a little bit inconvenient, I think. So start new batch. I don't know if that's particularly a descriptive name or not, but we'll leave it like this for now. So this is going to end scene, and then it's going to do this. So end scene obviously is going to copy the data, which I guess we should probably bring out into its own function so it makes more sense. But it's basically going to copy the data to the quad vertex buffer, and then it's going to flush, which is going to render everything and increase our draw calls and do all of that stuff. And then we're going to, without rebinding the shader or resetting the projection matrix, we're going to just reset this stuff because that's the important stuff. And then we're actually going to, we'll continue on with everything else. So instead of doing end scene, begin scene, we're just going to do start new batch, and that's it. So yeah, I can't say I'm 100% happy with this because obviously we do have some code that we're repeating, and if we add another kind of variable that actually needs to be like reset or something like that, we're going to have to add it to both begin scene and also start new batch, which isn't great. But yeah, this is basically just going to like flush and start new batch. And again, I don't know with the name. I think maybe we'll just call this flush and reset. I think that may make more sense. So flush and reset will actually end the scene and then reset everything rather than start new batch. So that way, if we read this and we see, okay, if the data is above max indices, we'll flush and reset. Okay, so I think that's going to be fine. Okay, so quad index count max indices. I think like that, all of this should be correct, but we'll have to test it out and stuff because I am just writing this on the fly without having tested it first as usual, because you know me. All right, so we're adding these to all the functions, obviously. I think that's it. Okay, so now what we're gonna do is on ImGUI render where we have our square color, I'm going to add some, which I don't think we even use, do we? M square color. Yeah, that's old. Okay, whatever. I'll still keep it around for like, in case we want to use it again, I guess. What I'll do is I'll say ImGUI text, and we'll say renderer 2D stats. So we'll make a bunch of these. And then what I'll do is I'll have something like, we'll have draw calls. Let's see, draw calls, which will be, and then we have to get the stats obviously. So we'll do renderer Hazel renderer 2D, renderer 2D get stats. I'll just assign that to auto here. Get stats, and then we'll do stats.drawCalls, stats.quads, quad count. And then I'll make 2 more that are just gonna be vertices and indices just for fun. And we can, we can have memory used and all of that stuff if we really want. So get total vertex count and get total index count as well. So this is, again, just before we reset the stats. That's what it's going to show. Okay, let's just try and run this. So first of all, like, this should not have affected anything. I think we should see the stats obviously inside IMGUI, but in terms of rendering, it should still be fine, and it is. Okay, so if we expand this, you can see that we have 5 quads, 1 draw call, 20 vertices, 30 indices. Okay, makes sense to me. So now one of the things that I want to do is say that our max size is 2. And that way we can easily test to see whether or not our limits and like all the flushing, like flush and reset that we've added, whether or not that actually works. So if I come over here and I make max quads 2, okay, which is quite fun. Don't think we'd ever have this, but let's see if it works. And you can see we crash. So that's going to be interesting. I wonder why we crash. So our index count is 18 here. Well, where do we crash exactly? Access violation. Okay, invalid value, invalid offset and or size. So this is good because this is us testing like kind of edge cases, I guess. Even though this isn't really normal for us to have this here, it's still very interesting. So let's see what's happened. So okay, so it's called flush and reset, obviously. And we're inside end scene now. End scene calls flush. What's the data size? 528. That seems, I guess that seems reasonable. 528. I mean, for what? For 2 vertices? That does seem a little bit high. 528 bytes. Is everything happening correctly here? It looks like it. Quad vertex buffer base. I guess we can, yeah, 528. Data size. Buffer pointer. We definitely reset that here after end scene, but we haven't actually done that yet. So we've tried to draw our quad. It's impossible to tell whether or not max indices is 12, index count is 18. Yeah, because we've okay, I think we have an issue here. Yeah, of course we have an issue here. My bad. Everything's fine. It's just my bad. So we need to actually, yeah, we need to do that because it is exactly a multiple of 6. So we'll just add that in. So let's see. Because if we try and draw 2, this will be 12. And so will the max indices will be 12. Quad index count will be 12. That's 12. That means we can't draw any more. So I was just wrong. Just flat out wrong in the first... in my first kind of thinking over here. All right, so let's just double check all of these. Where's this? Oh, good. I thought we missed this function. Okay, good. Let's try that again. So that was fine. That was just a crash inside the driver because we overflowed our vertex buffer. All right, so we still draw everything. You can see now it's in 3 draw calls, right? Because we have 5 quads. So obviously if we have 2 quads per draw max, 5 sounds right. And then everything else is here as well, which is good. Okay, now let's try and draw something a little bit more complex just as a bit of a stress test. And we'll probably end the episode there. So what I'll do is I might actually even start a new scene to make things more interesting. Not that we need to, but we will because we want to test that out. And what we'll do is we'll write a for loop, maybe, that goes from like, let's see, -5y, maybe. And we should try alpha blending. And there's a lot of stuff we need to try. All the way up to 5. This isn't the most efficient way of doing anything, really, but whatever. We'll increment this by 0.5, maybe. So that should give us, what, like 20 quads on one axis. We'll do the same for x. And I'm just going to draw a quad. It's not going to be rotated or anything. We'll just draw a normal quad. And then what do we have? So position. So position, we'll just do xy. Now size, now 0.5 is kind of our size. I want to have a little bit of a spacing, I guess, between them. So we'll do like 0.45 for the size. And then what do we have here? Our color. So the color, what should we do with the color? We can draw them all one color. That may be slightly boring. We could try and go with a gradient. So let's say float, we'll go with a red gradient. So we'll say the red color is going to be, now it's between -5 and 5, but we probably want to, I'll make this I'll actually make this a vec2. So this is going to be our RG, red and green color. Or maybe red and blue, because I don't like green. We will say x will be red. So we'll say x plus 5 divided by 10, right? So what this will do is we'll increment x by 5, meaning instead of being negative now, it's going to be in a range between 0 and 10, and then we're dividing it by 10 to get it into the range of 0 and 1, which is what we want for our color. And then for our y color, we will do, I might as well just call this color, to be honest. I don't know why I'm making it difficult for myself. Green will keep on like 0.3 or 0.4 maybe, and then the y-axis, so the vertical, will be our blue color. So we should get a nice kind of gradient of like really probably green all the way up to like purple or something. Anyway, that looks good, I think, except this GLM does not like my code. What's going on here? Oh, it's a vec2 still, vec3. All right, so now we have a color, except we also need, it actually needs to be a vec4. So let's set this. I don't know if blending will work. We can try it, but let's set it to 1 for now. So this is now our color. Okay, and this isn't happy because I didn't put these inside here. All right, so now we should be drawing a whole nother grid of little squares, and we are, okay? So we have 203 draw calls now, which definitely is not very efficient. We have a whole grid. I guess it looks correct. I don't know, it's hard to tell because it looks a little bit crazy, but yeah, there's our green all the way up to our kind of purple/pink. We've got orange down here. Yeah, looks decent. Let's maybe up this from like, 203 draw calls. Let's tell our batch renderer that we want to maybe render it in, well, let's try 1 draw call. So let's reset this back up to like, well, we'll put up to 20,000. And then we'll see if that renders in 1 draw call. It renders in 2 draw calls. Really? We have more than, how many quads do we have? 405. Oh, okay, that makes sense though, because we remember we're beginning another scene. We've got 2 scenes, even though they're technically the same. Okay, that looks good. Let's try and blend them for fun. We'll see if this even works. I'm not really sure if it will, but let's check it out. So for this, we'll set this to like 0.5, and we may get some nice transparency because we are rendering the grid first, and I expect, well, I mean, it should work. Yeah, there it is. Okay, so we're getting properly alpha blended sprites here, which look pretty good. Let's go ahead and just make our grid larger though. We'll start to make this scene look kind of half decent maybe. So instead of having an off, well, yeah, we'll make this like maybe 20 by 20. And then we'll make this from -10. We'll change the anchor point to -10, and then we should be okay. And by anchor point, I mean the kind of position. All right, so looking at this, that did not seem to work at all. What's going on here? Because the origin is the center, right? So why is that not? We're scaling it up 20 and we're translating it -10. I mean, that probably should have worked. Why is that not showing up in the center? Everything else is, right? I think it should be. And of course, this is just another case of me being an absolute idiot. Because obviously if 0 is the middle, you just leave it at 0 and you get the middle. So that's perfectly the middle now, which is good. So we have this kind of large quad texture, which is like our backdrop. And then we have this nice kind of rendering, all of this gradient. And we might even up the alpha a little bit just to make it look a bit nicer, maybe 0.7 here. Okay, that's pretty much it. That's what I wanted to do today. So you can see that we can render, we could have rendered this in 1 draw call, clearly, but we just chose not to. So we have 2 draw calls, 405 quads, 1620 vertices, and 2430 indices being rendered in 2 draw calls now, because we've separated them into 2 scenes. So just as a little test, if I get rid of the end scene, begin scene, then obviously this should just work. Yeah, and you can see it's now 1 draw call. So that is good. That's what we want. And then finally, I guess one last thing that I'll do is I will change this to be just, you know, so we have 400 quads. Let's make it 100 quads per draw. So this is a little bit more, I guess, realistic than 2 as a test. Not that I expect this not to work because we've tested pretty much everything else. Yep, we have 5 draw calls now. And finally, as just a little fun thing, let's change this to 1 quad per draw. So now we should have 400 draw calls, 405 draw calls. Everything still works. Everything still runs pretty quick, to be honest, because, you know, we're not really stressing it out too much. And I guess, fine, we'll make it so that we draw an absurd amount of quads. So let's go ahead and change this to like 0.1. And then we'll still keep everything the same. And I don't know if this will work or not, but I guess we're going to see. Okay, it is running very slowly. So we have 2 draw calls at the moment. We have 10,000 quads. And we have 61,000 vertices, 40,000 vertices. It is running quite slow though. It might be because of all the alpha blending. Although I don't really expect it to be that. I don't think so. I think it's most likely all the math that we're doing every single draw. Yep. So the best way to speed that up would just be to try to do that in release mode. And I think it will be good. And then in the future, we can, of course, address that and probably make it a bit more cache friendly and deal with that. Because we definitely need, like, I don't know, my goal for this is to be able to draw maybe like 100,000 quads or something in a draw call at like 60 FPS. So yeah, I mean, it's running super smooth now, as you can see. We're drawing 10,000 quads in 2 draw calls. Super smooth. So yeah, it was probably just all the mathematics, like all the adding and stuff that we were doing for each vertex. When we were running it, let's change this back. When we were doing it in debug mode, because that stuff will kill you if you're not using like SSE and all of this other stuff and optimizations basically. All right, cool. So for our test, 2 draw calls, 405 quads, everything looks pretty good. Next time, what I really want to do is basically, I guess, maybe incorporate some more textures, get it to, I don't know, we could try build some kind of scene. If you guys have any suggestions, I'm obviously going to push this code right now to GitHub. So you'll be able to, excuse me, you'll be able to download this and maybe try and construct some kind of scene if you so desire. If you come up with anything interesting, then post it on Discord. Discord, thechannel.com/Discord is how you can join that. If you're not in my Discord server, there'll be a link in the description below. There's a channel called Game Engine Series. If you join that channel, then you can post what you've done there, and then maybe I'll select something from there if it's a cool kind of scene that I like, and I can check out your code and I can integrate it, and we can come up with something. So you can make like this huge kind of scale tile map or something like that, like a little world out of all these things. And we can see if we can use that as a test case for optimization in the future. If nothing comes out of that, then I will just probably end up making my own scene, and we'll do that in the next episode. Anyway, I want to thank you guys for watching this series. As always, patreon.com/thechannel is the best way to help support everything that I'm doing here on YouTube. I've been doing live streams every single week, working on the 3D version of Hazel. And in fact, I've been doing live streams in general. There's a few complications with them. I want to start doing more public live streams. Like, for example, last night I was just like doing a little bit of Lua investigation for Hazel. Then we played a bit of Minecraft hardcore and did stuff like that. I did that on YouTube, but I'm probably going to do that on twitch.tv/thecherno in the future, as soon as I get my internet upgraded, because my upload speed is absolutely terrible. But finally I can get better internet in my area, so that's happening. But anyway, sorry, microphone. That's what's going on. I want to keep working on Hazel, and I want to, like, once we finish off with this renderer 2D stuff, I really want to take this into the direction of making maybe some kind of tool or an entity component system, and then integrating Lua as a scripting language so that we can actually start to build up that kind of like Flappy Bird clone that I made as a game, or any game in general. Thank you guys for watching. I will see you next time. Goodbye.